Nuclear submarines are the most expensive and sophisticated vessels patrolling our oceans. Working around the clock, their pressurized water reactors generate up to 190 megawatts, allowing underwater cruising speeds of over 60 kilometers an hour.
Diving now, diving now.
Here on board the Royal Navy's HMS Trenchant, over 100 naval personnel live and work.
There will be EOP pipes made.
Despite the sub's huge size, it's a cramped and difficult environment, and these guys have to cope with being submerged beneath the seas for months at a time.
Can I have a cheese and ham baguette, please?
Cheese and ham baguette.
That means providing a constant supply of oxygen. But taking enough oxygen in tanks would be impossible. So how do they do it? Well, this huge submarine is a bit like a giant fish. It absorbs its oxygen from the one thing there's no shortage of: seawater.
On deck, 60 metres.
An internal propeller on the side of the sub pumps up to 20,000 litres of water every day into a tank, where it's distilled to get rid of trace metals and salt. Next, the water is pumped to the air purification compartment, or APC. This contains a pair of electrolyzers. These work by passing electricity through the distilled water, separating it into its component elements, hydrogen and oxygen. That solves the problem of providing oxygen for the crew to breathe in. The next problem is what they breathe out, because every time they exhale, they fill the submarine with poisonous carbon dioxide. So the air is circulated through two chemical scrubbers. These units absorb the carbon dioxide into a liquid, which can be discharged into the ocean.
The actual air on board can be a better quality of air than actually to the outside of the submarine, especially when we dive, because we've got the CO2 removal and the oxygen and all that. There's a lot of gases sort of in the natural air that we don't have down here.
In case of an emergency, all of the essential units are duplicated, so that if one fails, there's a backup. Air is circulated through the vessel by a series of pumps, monitored and run from the control room. Maintaining clean air at the correct pressure in the sub is vital, and levels must be checked and maintained at all times.
50.
So every submariner is trained in how to take air readings. Using a handheld device called a Draeger pump, they can read the levels of any poisonous gases in the ship's atmosphere. The device works by passing air through a catalyst that changes colour to produce a reading. These readings are then logged and monitored by the ship's medical officer. This system is vital to maintaining life on board the submarine.
Atmosphere readings at the free deck, 50, 10, 11 clear.
But this network of vents and ducts pumping fresh oxygen around the sub means that there is one thing every submariner dreads: fire. It's a nightmare scenario.
Fire, fire, fire! Fire in the starboard side bunk space!
If the fire isn't brought under control swiftly, smoke and toxic fumes will spread rapidly via the air vents, making it impossible to breathe.
It's obviously one of the worst things that can happen to you. What we're trying to do is get the boat in a state where we can respond to that fire and also still achieve our tactical aim.
Fire, fire, fire! Fire in the starboard side bunk space!
To ensure the crew are prepared, they're regularly drilled in firefighting procedure. As soon as the fire is discovered, everyone swings into action. First, the details of the fire are relayed to the control room.
Fire, fire, fire! Fire in the forward book space!
30 revs, 10 down, keep 60 metres.
10 down, keep 60
Press on
metres.
ventilation.
From here, they have control over the submarine's ventilation systems, and the pumps circulating air are immediately shut down.
Stations. Fire, fire, fire.
Meanwhile, tactical decisions are taken in the wardroom, which becomes Damage Control Headquarters, or DCHQ. As with all areas of the sub, an emergency supply of clean air is on tap, and the team first ensure their breathing apparatus is functioning correctly.
DCHQ, closed up, ready to take the incident. I have the incident. Fire in the forward bunk space.
It's essential they keep the fire and smoke contained.
Jack, behind coming through! Behind coming through!
First on the scene are a team armed with chemical extinguishers. Their job is to try and stop the blaze spreading, and they're sealed from the rest of the sub by a smoke curtain.
Ship control, DCO.
Back in DCHQ, they ensure the ventilation bulkheads are shut down to prevent the further spread of smoke.
Bulkhead shut down, 76, 56 and 66 bulkhead shut down.
Roger, bulkheads.
Next, a further team of firefighters change into fireproof suits with full breathing apparatus. As soon as they're changed, they will have to try and extinguish the blaze using water from the sub's ballast tanks. These guys are at the front line in the fight against the fire. If they fail, the crew will be faced with the nightmare prospect of having to abandon ship.
Revolution 2-0. Live on the planes.
Back in DCHQ, they must quickly ensure the fire hasn't already affected the ship's seaworthiness.
We're now ensuring that the boat's in a material state to contain the fire, and also establishing communications with the team that is doing the fighting of the fire itself. We're waiting for reports back from them on the state of the fire, what sort it is and how bad it is, and then we'll make further decisions from that information.
With all air circulation systems shut down, they need to take atmosphere readings throughout the sub to ensure it hasn't already become contaminated with toxic gases.
DCHQ, 3 deck.
DCHQ, afternoon 2 deck. We're guard on the planes, Roger. 3 down. 4 down.
Once they have the readings, they can then decide whether they need to vent contaminated air from around the fire.
Atmosphere readings 51, nil, clear, Roger.
All of this has to take place while the submarine continues to remain operational and hidden.
Roger, bulkheads.
The problem they face is that if air needs to be vented, they will have to rise to periscope depth and potentially give away their position.
Ultimately, if we can stay deep, i.e. fully submerged and at depth underwater, then we will, because that's where we're safest and also our most covert. But if the atmosphere gets to the point where we need to exchange the atmosphere, then we may need to return to periscope depth to do that, or face prolonged periods on emergency breathing.
If the air throughout the sub has already become contaminated, the crew have one last resort to keep them alive. The sub carries what are known as oxygen candles. These generate oxygen through a chemical reaction, started with a small charge. These are used together with an emergency carbon dioxide absorption unit to keep the crew alive until they can reach the surface and abandon ship. Fortunately, today was only an exercise, and the firefighting team returned to base to strip off their breathing gear. And whilst this was just a practice drill, these guys are clearly exhausted. They know that if they ever have to do this for real, it's vital they rehearse every aspect of the procedure down to the last detail.
That's all reports in, sir. We're clear throughout the submarine.
Roger, clear, atmosphere is clear throughout the submarine. The atmosphere is inspect throughout the submarine.
Living and working on board a nuclear submarine for months at a time demands incredible discipline and self-sacrifice by its crew. As they stealthily slide beneath the waves, these guys know their lives depend on keeping this incredible machine running.